Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be taking a look at an example on the transformation of coordinates. Question reads, which transformation does not always preserve distance? So what we're going to do here is we're going to classify the types of transformations that we have here, okay? And then we're going to talk about the key thing that can help us to determine which one does not preserve distance. Basically, when distance is not preserved, we're thinking about a change in the size, right? If you change the size of a geometric object, um, then the distance is not preserved. We're looking at the distance between, let's say, 2 points on the side of the geometric object. And in the context of points, you just think about the distance between 2 points when you apply the same transformation formula to those 2 points. Okay? All right, so let's take a look at these ones that we have right here. The first one, if you notice, you just add in a constant to one of the points. Okay? When you add or subtract a constant to the points, what you're going to have is a translation situation. It's like a shift translation. So transformation number one is a translation. Now if you take a look at number two, you're just switching the signs of the coordinates x and y and also inverting them. This particular transformation here is simply a reflection. All right, you're interchanging the coordinates and then you're flipping it. So this is a reflection transformation. And then if you take a look at 3, you notice that there's a multiplication operation happening here. Okay? Whenever you're multiplying or scaling one of the coordinates, guess what? That is known as a dilation. You're not just simply moving points, you're actually altering the size of the distance between the 2 points. Okay? And then lastly, you just have 3 minus x and 2 minus y. If you combine these two, the negation of the sign and this constant that you're adding on, what you're literally doing in this example is shifting the points around. This is also another translation situation. All right. So if we take a look at these 4 examples, which one does not preserve distance? Now, a very important point you have to keep in mind is as follows. So let's put this down. A reminder, and that is that the distance, that's what's specified here, right, was being preserved. The distance, or think about it as length, between the points are not preserved under dilation. Okay. The reason why I put the word length there is to give you a visual. All right. When you dilate, you're either stretching or you're shrinking distances. All right. So that's why you do not have preservation of distance under the dilation transformation. All right. But on the other hand, they are preserved under what? Under reflections, translations, and rotations. Okay, so think about these 3 transformations as rigid motion transformations. Okay, when you say rigid, that means that the size does not change. All right, that's why they're called rigid. You're just moving it around and you're not changing the size. So when you just have a rigid motion transformation, which are reflections, translations, or rotations, the distance is preserved. Okay, so if you take a look at these 4 examples right here, which one does not always preserve distance? If you look at option 1, that's a translation, that's a rigid motion transformation. Distance is always preserved, check. Number 2 is a reflection. There's a rigid motion transformation, distance is always preserved. Number 3, dilation, distance is not always preserved. Okay, so distance or length is not always preserved here. So this is the answer. This is not a rigid motion transformation. For the last one, translation, distance is preserved in this one. So we can clearly see that the answer is option number 3. Thanks so much for taking the time to watch this presentation. Really appreciate it. Don't forget to support our channel. Tons of support resources can be found at mathgotserved.com or the links in the description below. If you have any questions about what we just covered or any geometry questions in general, specified in the comment section. We'll be more than glad to assist you. Thanks again for watching. We will see you in the next video. Goodbye.